Welcome to the deep dive. Today we're digging into something pretty wild. It's the TESSERACTFRHOMBIC clip keyboard, Canon core specification V1.0.
And this isn't just software. The source describes it as a closed universe. The rules are, and this is a direct quote, deterministic, finite, executable, and unforgiving.
Unforgiving is the word. Our whole mission today is to figure out why this system is so brittle.
And it all starts with time. The system's entire reality is built on what it calls temporal sovereignty.
Meaning what, exactly?
Everything is based on a single immutable record.
Right.
It's governed by a fixed tick quantum, delta tau, of exactly 236 milliseconds. And that's it. Not a nanosecond, more or less. The spec is so clear on this. No flow, no overlap, no retroaction. Just a hard series of these 236 millisecond snapshots.
Right. And what's crucial is how that snapshot gets triggered. Before any tick, you have something called the PLCD.
The pre-legisign contact declaration. Exactly. You can think of it as the system's raw physical observation. It's described as silent, untimed, pre-tick, and non-adjudicated. So it's the raw sensory data before any judgment. But here's the kicker for you. This physical state has to completely stabilize before the 236 millisecond tick is even allowed to fire. If it's unstable, the tick fails. Instantly.
So the physical world is the gatekeeper of time itself. That's incredible.
It is. The system values that mechanical certainty over everything else. So once it's stable, the RK axis core is red.
And this is the core data.
The core data. And it's derived entirely from the physical grip class. It's never, ever chosen by the operator.
It's read, not written. And it follows this strict sequence, a gray cycle order. You have 4 codes, 0, 0, 0, 0, 1, 11, and 10. They map to these foundational concepts like unilateral continuity or intact opposition.
And that input, that physical grip, dictates the entire phonetic architecture. That 236 millisecond tick is broken into really strict time slots for 3 syllables.
Geosyl, hec XLL, and verbsyllable, and then silence.
And you cannot violate those slots.
Right. The source says if you utter the GAULs, the geometry syllable, even 1 millisecond outside a 0 to 59 millisecond window, that's it.
Immediate invalid operation. The whole thing just stops. It's like trying to sing over a perfectly timed orchestra.
And what's interesting is how the speech itself is treated. Some of it has meaning, some of it doesn't.
Right.
Well, exactly. The geometry syllables like KROA, their meaning depends on the state, but the HX encoding, the syllables like NA or SO, the spec explicitly says they carry semantic load, none. It's just pure data. Mechanical communication.
Which fits perfectly with how the system judges everything. Each tick is instantly judged by comparing the actual physical contact, C, against the expected contact, E.
And that's done with Hamming distance, right? Just counting the bits that are different.
Yep.
And that gives you one of 3 states, valid, drift, or invalid. If the Hamming distance is just 1, the operation enters drift. And drift is tied to a physical component, the anchor.
Critically tied. The TopYellow1 component defines the positive Y direction. If you lose contact with that anchor, even if your data is perfect,
the system downgrades you. A valid operation becomes drift. It's a physical warning light.
And if you stay in drift for 3 consecutive ticks, that's less than a second, the system terminates.
So termination happens automatically from an invalid op or from losing that anchor.
Or you can do it yourself. You can speak the token FFNULL, which is pronounced SOSONA. The cost of any error is just absolute. The source sums it all up with invariant 4. Geometry and mechanics dominate meaning.
It does. And that brings us to the most, I think, fascinating part of this design, the VRB system.
Okay.
So the VRB SYL, the final syllable, is where the operator declares their belief, their intention. But invariant 5 says that VPRED, the system's verb prediction.
Wait, let me guess. It doesn't update from the belief.
It updates only from the actual physical outcome of the tick.
So think about this for a moment. You speak your intention, and then the system immediately judges the physical result. Doesn't care what you said you wanted, it only tracks what actually happened. Your belief is logged, but the system's internal knowledge, VPRED, tracks reality. And the state transition function insists that speech precedes judgment.
So what does it mean to build a system like that, where your stated belief is immediately and unforgivingly superseded by the outcome? Go explore that moment, that gap between human intention and mechanical fact.
Welcome to the deep dive. Today, we're looking at a document that is incredibly rigorous. It feels less like software and more like a law of physics.
It really does.
It's the TESSERACTFRHOMBIC clip keyboard Canon core specification V1.0, We'll just call it the Tesseract spec.
A lot easier to say.
And our mission today is to unpack its core idea, which the document calls absolute temporal sovereignty.
And that phrase, that's really the whole key. This spec isn't about, being flexible. It's about killing ambiguity with just brutal time enforcement.
So what does that look like in practice?
Well, it starts with the tick quantum. It's the basic unit of time, and it's set at exactly 236 milliseconds.
Exactly. So no plus or minus.
Zero tolerance, no negotiation. That time unit is, well, it's immutable. It guarantees only one record can be made per tick. The spec is clear.
Yeah.
No flow, no overlap, no retroaction.
And what feeds into that tick is also interesting. It's something called the PLCD.
The pre-LEGISIGN contact declaration.
Right. And you should think of this as the physical world needing to stabilize before that 236 millisecond clock even starts.
Exactly. It's silent, it's untimed, and crucially, it's non-adjudicated. It just provides a 4-bit contact, C, and a rotation vertex, R. It separates the raw fact from the system's judgment of that fact.
So if the physical reality isn't stable, the tick just doesn't happen.
It can't. The precondition isn't met.
Okay, so let's get into this 236 milliseconds. The first thing that happens is the rotational key, or RK.
Yes. And this defines the physical axis, Y, X, Z, or even Y plus X.
And here's the kicker, and I had to read this twice. The RK is always read. It's read from the grip class. The user cannot choose it.
They cannot.
Doesn't that feel completely counterintuitive for an input system?
It does, but that rigidity is the entire point.
Yeah.
The system processes what is, not what a user wishes was. And that clock, that quarter of a second, is chopped into these sequential mandatory time slots.
Syllables, right. And they are incredibly short.
Unforgivingly short. You get 0 to 59 milliseconds for the GEOSITEL.
Then 60 to 118 for the EXYL.
And a 119 to 177 for the VR-BELSYL. And if you're not done by then?
You hit the wall. The last slot, 178 to 236 milliseconds, is just silence.
And that silence is terminal. It's over. What's fascinating is the detail, like the hex encoding in that HEXSYL slot. 0 is NA, F is SO. But the spec says, and I'm quoting, semantic load, none.
So it literally means nothing. It's just a placeholder.
Exactly. It shows the system only cares about timing and geometry, not human meaning.
Okay, so with the timing locked down, how does the system actually judge the input? How does it decide if it's valid?
It's purely mechanical. It just checks contact validity, compares the contact it received, C against the contact it expected based on the RK.
And the outcome is based on Hamming distance, right? Just counting the bit errors.
That's it. 0 errors, you get valid. 1 single error, it's called drift, but 2 or more.
Immediate invalid. And the system just terminates.
It terminates automatically, no second chances.
Which brings us to the physical invariants. The biggest one seems to be the anchor.
Oh, absolutely. The anchor is everything. It's defined by a physical object, TopYellow1, and that object physically defines the plus Y axis.
And if you lose sight of that anchor...
Even if your input was perfect, a valid gets downgraded to drift.
And that's dangerous, because if that happens for 3 ticks in a row...
You're out.
Yeah.
Automatic termination. And if you get drift for any reason, whether a Hamming error or anchor loss, you get 1 and only 1 chance to recover.
Let me guess, it's a very specific action.
Of course. The very next tick's verb ESYL must be the token SO for same. You fail that one attempt and you're immediately invalid.
Wow. So to recap for you, the system is deterministic, executable, and completely unforgiving. And it all seems to rely on that physical TopYellow1 anchor.
It really does. The big takeaway here is that for this system, geometry and mechanics just crush meaning. The system's velocity prediction, its VPRED, tracks actual physical outcomes, not what you intended or what you believe.
So that leaves us with a final thought. If this whole system is anchored to these fixed, physically defined rules, like plus Y is always TopYellow1, what does it possibly mean when the spec says speech precedes judgment?
That is the question, isn't it?
Is speech just the physical act itself, and is judgment just the system reporting whether you did it inside that 236 millisecond window? It's something for you to think about, especially when you consider free will in a world that could be, well, perfectly deterministic. Welcome to the deep dive. Today we are getting into a specification that is really something else. It's the TESSERACTFRHOMBIC clip keyboard, Canon Core specification V1.00, and if you want to see what a truly unforgiving system looks like, this is it.
It really is. The entire architecture is built around this one incredibly strict constraint they call temporal sovereignty.
Temporal sovereignty. What does that actually mean in practice?
It means the system lives and dies by the tick, a single precise tick of quantum they call delta ta. That is exactly 236 milliseconds long.
236 milliseconds. That's the entire universe for this machine.
That's everything. You get one immutable record per tick. And the spec is, well, it's explicit. No flow, no overlap, no retroaction.
So if you miss that window, what happens?
It's not just an error log. The tick simply fails to occur. The whole state machine just stalls.
Wait, hold on. So if the user doesn't stabilize their input before that 236 millisecond moment,
Yep.
the system just stops. It produces nothing.
Nothing. It stalls. That sounds hostile, I know.
It sounds incredibly hostile. It's like it's punishing you for being human for a microsecond of error.
It absolutely is. And that input is what they call the pre-legisign contact declaration, or PLCD.
Okay, so this isn't a message you're typing.
Not at all. It's raw physical fact. The spec says it's silent, untimed, and non-phonetic. It's just 4 bits of contact data and some rotation data. That's it.
So you have this raw physical data from the PLCD. How does the machine organize it? I saw something about an RK core.
Right. The RK core is the internal state. It's always in one of 4 states, 0, 0, 1, 11, or 10. And it cycles through them in a fixed gray cycle order.
And crucially, the user isn't choosing that state.
Never. The spec is very clear. The RK is read from the grip class, which is, your physical orientation on the device.
So your body's position dictates the machine's state.
Exactly. And that state then carves up that tiny 236 millisecond window.
How so?
It's brutally divided. The first 59 milliseconds are for a geometry syllable, the GEOSY. The next block is for a hex value, the HEXSYL.
And the third?
The third is the VRBASYL, the action. And then, get this, the final quarter of the tick is dedicated entirely to silence.
Required silence.
Required and terminal.
Okay, this is where it gets wild for me. The physical facts literally dictate the language.
That's in variant 4. Geometry and mechanics dominate meaning.
Give us an example.
Okay, so if you're holding the device in the 0-0 axis on the OA geometry, the machine is forced to output the syllable KROA.
You have no choice. The mechanics produce the word.
Precisely. And to prove the point, look at the SX encoding. The syllables for numbers, like NA for 0 or SO for F. The spec explicitly says they have semantic load. None.
They're just noise. The meaning is only in the physical structure.
The meaning is in the hardware you're physically touching.
Wow. So after all that, the system then has to judge if what you did was even acceptable.
Right, the verdict system. You'd use a Hamming distance to check how many bits you got wrong between the contact you made and the contact it expected.
And the outcomes are valid, drift, and invalid.
Yep. 0 mistakes, you're valid. 1 mistake. You're in a probation state called drift.
And 2 or more.
Straight to invalid, no appeal.
But even a perfect valid input can go wrong, can it? There's this anchor condition.
Yes, the physical anchor. It's a sensor, TopYellow1, basically checking if your hand is still aligned with the device's main axis.
And if it's not.
If you lose that anchor, even a valid state is immediately downgraded to drift.
And once you're in drift, you're on thin ice.
Very thin. You get exactly 1 shot at recovery. The next tick's verb syllable must be SO, the recovery code.
And if you fail that one attempt,
the system flips to invalid, and that's a terminating condition.
it's just down.
Game over. That or 3 consecutive ticks where you've lost the anchor. The system is designed to be self-terminating.
Unforgiving is the word. So boiling it all down, the core idea here is that the physical world, the mechanics of the grip, is the real language.
It's read first, and it dictates everything that follows. Which brings us back to one of the most fascinating parts of the whole spec. In variant 2, it says, speech precedes judgment.
Speech precedes judgment.
Think about what that means. The system has to complete the entire act of communication. It has to utter those syllables based on your physical state before it's even allowed to check if that state was legal or correct.
So it speaks first, asks questions later.
It has to fully declare its state before it can even validate that same declaration. What does that tell you about a system's priorities? That's really something to think about. Okay, so we're doing a deep dive today into a document that is, let's just say, intensely rigid.
That's putting it mildly.
Yeah, the TESSERACTFRHOMBIC CLIPKEYBOARD CANON core specification. And it defines itself with these 4, really heavy words.
Deterministic, finite, executable, and unforgiving.
Exactly. Unforgiving. So our mission is to figure out what that actually means for anyone who tries to, operate this thing?
You know, it's almost less of a system and more like a mechanical dogma.
Dogma.
And the absolute foundation of that is this concept they call temporal sovereignty.
Temporal sovereignty. What does that break down to?
It just means the system dictates its own time, its own universe, really.
Yeah.
And the speed of that universe is set by the tick quantum.
That eat.
Exactly, too. And it is locked at exactly 236 milliseconds. That's the heartbeat. It's immutable.
And within that tiny window, just one single perfect record can be generated. The rule is no flow, no overlap, no retroaction.
A clean slate every single time.
Right, but here's the part that really gets me. The physical world, your hands, they have to be perfect before that clock even starts. This silent precursor.
The PLCD. The pre-legisign contact declaration. And the spec is so clear about what that is. It is explicitly untimed and non-phonetic.
So it's not speech. It's not an action in the way we think of it.
No, it's just raw physical fact. A 4-bit contact, C, and a rotation vertex, R. That is all.
Just where you're touching it and how your wrist is turned.
Precisely. And here's the really unforgiving part. If that physical state doesn't completely stabilize before the tick starts,
The whole thing just fails.
the whole thing fails. You get no tick. The universe of the keyboard it doesn't begin.
That is an incredible demand for precision. It's
Yeah.
it's inhuman stillness. So, okay, let's say you achieve that. You're perfectly still. The system then reads what it calls the RK axis core.
It does. Your physical input actually forces the RK core into a specific state. It's a cyclical finite set. Only 4 states.
0, 0, 1, 11, and 10.
Yep. And you don't choose it. The system reads it from what it calls your grip class.
So your grip literally determines the entire operating mode.
It determines the spatial AXIS. YX, ZY plus X. These map to these very abstract concepts like unilateral continuity or intact opposition. The geometry of your hand is the state.
So you're not choosing a function. Your grip is the function.
Yeah.
Okay. And this is where it gets, I think, even more rigid. The transformation into actual sound. The moment that 236 millisecond tick starts, it's just chopped up.
Brutally is the right word for it. You have 4 distinct time slots.
And they are tiny. Each one is less than 60 milliseconds.
Right. Geosyllal, hexsyllal, verbiscallal. And then, this is the key part, the final 58 milliseconds are mandatory silence.
Mandatory silence. So you have to speak a component, then another, each in less than a sixth of a second, and then you must be silent.
Exactly. And if you violate a slot, if you make a sound in that silent period,
It's an invalid operation.
instantly. And on top of that, the phonetic encoding has to perfectly align with the geometry derived from your grip.
Mm-hmm.
So the hex encoding is just a fixed table. 0 means NA, F means SO. But if your grip implies one thing and your utterance implies another,
Invalid.
it always comes back to that core rule. Geometry and mechanics dominate meaning.
Okay, which leads us straight to the validation check.
Yeah.
The system is constantly checking you, isn't it? It's not trusting your intent.
Not at all. It's checking the physical outcome using Hamming distance. It's basically comparing the contact you actually made against the contact it expected based on your RK state.
So it's like checking a key against a lock, bit by bit.
That's a really good analogy. If the distance is 0, it's a perfect match. That's valid.
And if it's off by just one single bit,
Then you get a drift. It's a momentary slip. Anything worse, a distance of 2 or more, and it's an immediate invalid.
an invalid means game over.
The system just terminates itself.
That's it. End of story. But drift is fascinating. That's the one tiny crack of, human fallibility the system allows.
You get one chance to recover from it. One chance. If you get a drift, your very next tick's verbo or so L, that third syllable, must be SO.
Which means same.
Right. You have to immediately acknowledge and reaffirm the slightly failed state. And the specification is so blunt about it. It says one attempt only. You fail that, and you're right back to an invalid termination.
So when you pull it all together, what are the fundamental invariants of this whole universe? We're left with the absolute dominance of mechanics. Geometry and mechanics dominate meaning.
And that other unforgiving truth that silence is terminal, that last silent slot isn't a pause, it's a rule. It's an endpoint.
The specification even says speech declares belief, which sounds like it's about your intent.
It sounds like it, but the system doesn't care about your belief. It doesn't record your intent. The final record, what it calls VPRED, it only tracks outcomes. The cold mechanical accounting, it adjudicates your belief against its own physical reality.
Which leaves us with a pretty provocative thought for you to mull over. This clip keyboard canon is described as unforgiving, It demands physical stabilization before the tick and rigid phonetic timing during the tick. So what does that imply about the ideal user or operator of such a demanding architecture? Who is this system actually built for? Is it even expecting a human to use it?